You learn 6 types of separation. That's decanting, filtration, evaporation, simple distillation, fractional distillation, and chromatography. Okay, you can either use this when it's done, or you can just use the one I wrote for your class earlier on. Okay, so decanting, what's the example? Decanting is when you let something settle, such as if you have a beaker of water and mud, and the mud eventually sinks to the bottom. Okay, this also works for 2 liquids that don't mix with each other. It's not miscible, like maybe oil and water. So it will form 2 layers by itself. Then we just pour out the top layer. So that is decanting. Okay, filtration. What do we use this for? So filtration is the one where you have filter paper and you let the mixture go through here. So this is to separate 2 substances. One dissolves and one does not dissolve. The one that dissolves in the solvent will fall to the bottom here as the filtrate. So the one that dissolves is down here. And the one that do not dissolve in the solvent will end up here as the residue. So we call what's down here the filtrate, and the one that's up here, we call it the residue. Okay, this also works for separation of a liquid and an insoluble solid, such as water and sand. So the sand will end up to be the residue and the water will fall to the bottom as the filtrate. So that works as well. Okay, the next one is evaporation. So evaporation is to separate a solution. So a solution has what in it? A solution would consist of the solute and the solvent. So we're trying to separate the solute from the solvent, and evaporation is when we want the solute. So the setup is you put an evaporating dish, put the solution here, and we heat it, say a Bunsen burner here. So we heat it to evaporate, and in the end, you will get the solutes here while the solvent evaporates. We can either do it halfway, we heat it halfway, and then we filter it. That's the method before this. When you get the crystals, we filter it. Or the other option is we heat it till the end, and in the end, there's only the solute left on this evaporating dish. Okay, so 2 ways to do it. Either you heat it totally dry, or you heat it halfway and then evaporate it. Simple distillation is again for a solution. And we want to separate the solute from the solvent. And this time, we want the solvent. So it's not the solute that we want. So we can't use evaporation method because the solvent will be gone after we evaporate it. So we'll use simple distillation. And remember, in a simple distillation, you do need a condenser. Okay, so the drawing looks like this. Water goes in from the bottom and comes up from the top. The reason is because we don't want the water to fall out. Then the condenser will never be full. So we want this condenser to be full of water, and inside you can see there's a lane that is for the vapor from this heating to go through. Okay, so when it passes the condenser, then it is condensed. and it'll become liquid and come out here. So your solute will be left behind here, and the solvent will come right out. So this is when we have a solution, and we want the solvent. It's not the solute that we want, because if it's the solute that we want, then we would have used the evaporation method. Next is fractional distillation. Now, how's that different from simple distillation? So simple distillation, there's only solute and solvent that you want to separate. So you just want the solvent out. Fractional distillation is if you have a few substance of different boiling points. So maybe there's like 4 substances with different boiling points that is inside the round bottom flask. Okay, the setup looks like, I'm not going to draw that here, but it's in your textbook and it's also in your class notes. It looks like this. So this is how fractional distillation is set up. You have the mixture here. So they might have different boiling points here. And the one with the lowest boiling point, it's going to get boiled first and it will be heat up. It forms steam here. And when it travels here, it will be condensed and you'll collect the first substance. That is the one with the lowest boiling point first. Same story with simple distillation. The water must go in from the bottom and comes out from the top so that the condenser can be filled up with water. Okay, so that's for fractional distillation. You have a few substances of different boiling points. The one with lowest boiling point will be collected first. You may refer to chapter 6.15 in the textbook to have a look at a picture. Okay, it's not too different from simple distillation, just a little bit different. Okay, and the last one, chromatography. These are for things that dissolve to separate a few substances that dissolves in the same solvent. Okay, example, dyes, as in coloring. So this is the one where you have a chromatography paper. We have the baseline at the bottom, and we have the solvent front at the top. And here is where your mixture starts. You have a container, it's a closed container, and you have a solvent at the bottom of the container. So this is clipped upright. Okay, so we clip this so that it's upright. Capillary action is going to bring this solvent up the paper, chromatography, and while it goes up the paper, then the mixture will also follow, but in different speed. So maybe, for example, the green traveled here, red color traveled here, and probably say blue color traveled here. So I can say that, okay, the blue travels the fastest. That's why at the end, it is the furthest from the baseline. And the green is the slowest because in the end, it's still closest to the baseline. So these are for things, these two separate things that dissolve in the same solvent, which is this solvent. Usually used for dyes.